All right, so here we are up to part three. Part three is asking us to determine the coefficient of static friction. So to figure out the coefficient of static friction, we're going to need to know the force of friction, which we have. But there are some interesting points here. The force of friction, right? If you look up, if you might remember, the force of friction is calculated by the equation mu, the coefficient of friction is what we're solving for, times the normal force. So here we have to solve for mu. A couple of important things. This is mu, mu, Greek letter mu, and that's the symbol for the coefficient of friction. And this is the normal force, the support force, how much the ground is pushing up. Force spelled that way. All right, so if we go back to our picture now, here the normal force is in the vertical direction. So if we need to calculate, we know what the force of friction is, but to figure out the force of friction is mu times the normal force. To figure out mu, we need to know the normal force. The normal force is in the vertical direction. Here we solved some of the forces in the x. To figure out the normal force, we have to do the sum of the forces in the y direction. So we're going to do the sum of the forces in the y direction. Changing colors once again. Let's go with a nice dark color there. All right, so here we go. Sum of the forces in the y direction. Well, what forces are acting in the y direction? We know gravity is down. Gravity is down. We're going to make that negative. Minus gravity. Okay, what else is in the down position? Part of our applied force was down, right? This is our 20 newtons. That's to the side. This was 20 newtons this way at that 30 degrees. Well, some of that 20 was to the side. We figured out that that was 17.3 newtons to the side, but some of that 20 is down as well. Well, that would be, if this is now, here's our right triangle, right? So here's the adjacent side to the 30. If this is the 30 degrees, this is the opposite side, opposite of the angle, right? The trigonometry, tongue-tied there, trigonometry, that's going to be the sine function. So we need to do minus the force applied in the y direction plus the normal force. So this is going to be minus 49 newtons minus, let's see, this is going to be 20 newtons times the sine of 30. This is going to be 20 newtons times the sine of 30 degrees. Sine of 30 degrees is a half times 20, 10 newtons. The applied force in the y direction, the part of that 20 that's pushing down is 10 newtons plus the normal force. And again, it's not moving up or down, so the sum of the forces is in equilibrium because it's at rest. The sum of the forces is 0. So 0 equals negative 59 newtons plus the normal force. Well, the normal force must be 59 newtons. Negative 59 plus what equals 0? The normal force equals 59 newtons. Normal force is 59 newtons. Well, that's not really exactly everything. Here we want to figure out the coefficient of friction. So this is what we have to do. Again, we know the force of friction. The force of friction we figured out before was 17.3 newtons equals mu times the normal force we just figured out was 59 newtons. Divide both sides by 59. Get mu by itself, right? Divide this side by 59 newtons. Divide this side by 59 newtons. So 17.3 newtons divided by 59 newtons equals mu, right? Here are 59 newtons will cancel out. What do we get here? Let's grab a calculator because I should have this in front of me. 17.3 divided by 59. 0.29. Mu, oops, not, I don't want to erase. Do not want to erase. Get out of that erasing part. Mu equals 0.29. That's our answer. Okay, that's the last part.